Number to record.
Hello, my name is Arjun, and along with my colleagues, Pam, Julya, and Dannya, as well as our faculty members, Dr. Kokoni and Dr. Kriadis, our team over the past year has undertaken the characterization of infant reaching motion for action recognition, which is a stepping stone towards our ultimate goal of improving infant mobility. So why is studying how infants move an important field of research? Infant motor actions are an emerging research direction with the aim of creating vision-based action recognition approaches to produce autonomous closed-loop assistive devices. Such devices require control algorithms to recognize kinematic movement. However, many of the current action recognition approaches rely on adult source data, which does not prove to be useful when characterizing highly variable infant movement. Furthermore, current infant movement datasets do not particularly focus on reaching action. Hence, the three major goals of our project include defining what constitutes a reaching action, outlining a methodology to characterize reaching actions in infants, and developing an annotated reaching dataset to be used in the action recognition network. Given our objectives, it is first important to define what action recognition entails. Broadly speaking, the term describes the identification or prediction of a particular agent through a series of observations. For our intents and purposes, we have specified this definition as the identification of human movement in order to train neural networks. This sort of characterization can be accomplished via vision-based action recognition techniques as depicted on the image to the left. Before moving on to action recognition, as it relates to the action of reaching, I would like to take the time to explain why our research focuses on reaching action in particular. Reaching, in terms of developmental milestones in infants, is one of the first to emerge, and particularly one of the first actions wherein the intent of motor action is executed based on visual perception. Combining this with limited research in upper body rehabilitation, it proves to be an intriguing field of study.
We did base our definitions on previous studies, however, we shaped them to meet our purposes. Each reach was defined by a consecutive segment of at least 3 frames, where the infant's hand had no contact to the trunk, legs, or ground. The reach was also defined by 2 sub-actions, the onset and the offset. The reach onset is the first frame in which the hand, left, right, or both, move towards the presented object. At the end of the reach, or the offset, is identified as the first frame in which the infant intentionally touches the object. For our purposes, we only took into consideration reaching behaviors in which the infant was sitting. To accommodate for COVID-19 safety requirements, we relied on YouTube to obtain our data. This makes our data collection process different from the traditional form. Using keywords such as infant physiotherapy and baby-led weaning, we found 20 videos, 21 subjects, most of which were 6 to 12 months old. Of the 21, 16 were identified as neurotypical subjects and 5 neurodivergent. In each video, we made sure that 1, there was little to no camera movement during the reaching action, 2, the object was visible during the entire reach, and that 3, that the infant is up to 12 months old. As I previously mentioned, each reach was comprised of an onset and offset. To detail these crucial frames, we manually annotated on Cornea, an open source 2-dimensional motion software. At the onset, we identified which hand or hands the infant used and its position in relation to the infant's body, whether it was near the head, chest, abdomen, or ground, by placing a marker between the 3rd and 4th knuckle of the appropriate hands. At the offset, we made a similar annotation seen by the blue label. For both the object and the camera positions, we noted whether it was near the head, chest, abdomen, or ground. We also categorized the object the infant reached for and determined its position in relation to the infant, whether it was to the center, left, or right of the infant. Cornea provided us with coordinates of the markers we placed at the onset and offset in pixels. To measure these coordinates in centimeters, we calibrated the infant's cornea to 1.5 centimeters. Overall, we identified 86 left-hand reaches, 107 right-hand reaches, with a total of 193 reaches. The diagram below highlights the distribution of the duration of all the reaches in our dataset. The variability between the reaching action duration can readily be observed, though the majority lasts between 5 to 15 frames.
After reaching annotations, we annotate bounding boxes using Cornea. We place bounding boxes for the hand and the object from onset to offset using two markers on the top right and the bottom left, as you can see in these images. But since we cannot see the boxes, it is not accurate enough, and we cannot place both markers for the hand and the object in the same image. Therefore, the graduate students used an annotation tool to place bounding boxes in one image. Here is a picture with bounding boxes using an open source annotation tool. As you can see, compared to the previous image, the bounding boxes are clearly visible. The tool placed bounding boxes for 4 classes, which are infant, right hand, left hand, and objects with different colors, and extract the top left, height, and width. The object detection is trained using the real-time object detector YOLO with the COCO dataset. Our dataset contains both reaching and bounding box annotations. After the bounding box extractions, the graduate students built a machine learning algorithm named BabyNet. They compare the onset and offset taken from using the algorithm and the manually done annotations. These are the results that taken from training both large and lightweight networks. As you can see, even though the BabyNet has a low training and validation accuracy compared to the others, it provides similar results in precision and recall.
By tracking the trajectory and distance traveled by the hand from onset to offset, we would be able to provide the network with more information to improve in the detection of a reach. It is important to note that tracking is still a work in progress, but we hypothesize that in addition to improving the validation accuracy, it would also help identify which direction and which object the infant is aiming for in the case of having multiple objects at range. On this diagram, we can observe in yellow our contribution to this project. We compiled the dataset and created the reach annotations, some bounding boxes, and we tracked the trajectory of the reach. The bounding boxes started by us and perfected by the graduate and doctoral students were fed into the algorithm, and the results were compared with the manually annotated reaches by us. In the near future, we will finalize tracking the trajectories of the reaches with the hope to obtain more accurate results from the network. We have faced many challenges during our research. However, I will be focusing on just a few. Creating a database using videos obtained from YouTube gave us no control over the environment our subjects would interact with. So we had to adapt our research to their set on constrained environments. The Cornea Calibration was the tool that would allow us to turn the pixel measurements into centimeters by assigning the length of the cornea as a base measurement. Nonetheless, this brought some challenges since in most of the videos, the size of the cornea would change depending on how close the infant was sitting to the camera. In some cases, the cornea was not even fully visible throughout the duration of the reach. Infants were not only the ones visible on the clips. Usually, they were accompanied by at least one adult. And this caused some conflicts with the identification of the infant as the main subject of study by the network. The resolution and the frame rate of the original videos would vary greatly, even within the same clip. Thus, we had to be adamant with the specific requirements for the analyzed data. Through it all, collaborating on this project has been an honor, and we would like to thank our faculty mentors, doctoral and graduate students for their support and the opportunity to co-author a conference research paper that is currently under board review based on this work. We would also like to thank our audience for your time and attention during our presentation. Are there any questions we can address?